Hello everyone. Welcome to the Building Services Subject Lecture. Myself Vinod Shivkumar. Working as an assistant professor in the Department of Civil Engineering at KPR Institute of Engineering and Technology Coimbatore. Today we are going to discuss Unit 3, Mechanical and Plumbing Services in Buildings. We will cover the following topics. Introduction of mechanical services, lift, definition, types of lifts, design considerations, air conditioning, definition, different controllers, air distribution system, types of air conditioners, piping materials and fittings, plumbing fixture, water supply systems, designing plumbing systems, installation. Mechanical system, any building service using machines. They include plumbing, elevators, escalators, and heating and air conditioning systems. The introduction of mechanization in buildings in the early 20th century brought about major adjustments. The new equipment demanded floor space, and the design team began to include electrical and HVAC, heating, ventilating, and air conditioning, engineers. Heating and cooling changed dramatically. Modern buildings, with their large heat gains, turned central heating into little more than a supplement. Heat removal is a much more serious burden, especially in warm weather. The roofs of high-rises are occupied by cooling towers and mechanical penthouses. Entire floors are often dedicated to the containment of blowers, compressors, water chillers, boilers, pumps, and generators. The next topic is lift. A lift, or elevator, is a form of vertical transportation between building floors, levels, or decks, commonly used in offices, public buildings, and other types of multi-story building. Lifts can be essential for providing vertical circulation, particularly in tall buildings, for wheelchair and other non-ambulant building users, and for the vertical transportation of goods. Some lifts may also be used for firefighting and evacuation purposes. Types of lift, types of lifts. Designing buildings. Design consideration, safety, quality, aesthetics, the capacity during peak times, and the type of building in which the elevator is to be installed. A common residential lift is usually 3 wide by 4 deep or 0.91 x 1.22 m in dimensions. You can see in the picture the different types of lift. Now we will see about air conditioner. An air conditioner collects warm air from a given location, processes it with the help of a refrigerant and a series of coils within it, and then releases the cold air to the place where the hot air was initially collected. Virtually all air conditioners' system works on this principle. Most people believe that an air conditioner produces fresh air with the help of machines installed inside it, which can cause it to cool a room so quickly. Hence they say why it consumes so much electricity. However, this is a delusion. The air conditioner is not a magic device, as it follows a set of physical and chemical phenomena to cool a place very effectively. When you turn on an AC and set your desired temperature around 16 to 32 degrees, the thermostat installed in it senses that there is a difference between the room air temperature and the temperature you choose. Definition: air conditioning, often referred to as AC, A/C or air con, is a system used to cool down the temperature in an inside space by removing the existing heat and moisture from the room. Essentially, they work by taking warm air into a system and dispersing cold air, but there is much more to this process. During the air conditioning design process, HVAC engineers look at a wide range of different factors, but the most important to consider are the type of air conditioning system, the size of the system and the available space, ducts and ventilation, cooling loads, energy efficiency, cost effectiveness, health and safety requirements. Types of air conditioner: central air conditioner, ductless mini-split, window air conditioner, portable air conditioner, floor-mounted AC, hybrid/dual fuel air conditioner, smart air conditioner, geothermal air conditioner. Principle of air conditioning. An air conditioner in a room or a car works by absorbing hot air from a particular room, processing it into itself with the help of a refrigerant and a series of coils, and then releasing cool air into the same room where the hot air was originally collected. This processing is mainly carried out via 5 components. They are evaporator, compressor, condenser, expansion valve, refrigerants. How air conditioners control temperature. Most air conditioners control the temperature using a return air temperature sensor. Conventional air conditioners cool a room until the return air temperature matches the set temperature and then stop. When the return air temperature gets higher than the set temperature, it runs again and the cycle repeats. On the other hand, inverter-type air conditioners reduce cooling power to maintain the set temperature rather than stop. However, not all air conditioners use a return air temperature sensor to control the temperature. Below are 3 types of temperature control method commonly used in air conditioning. Return air temperature sensor. Indoor unit room temperature sensor. Thermostat. Return air temperature sensor. Most air conditioners have a temperature sensor located at the return air section. It is assumed that the return air temperature represents the current room temperature. Hence, the installation of the AC must have good return air in order to better control the room temperature. Indoor unit room temperature sensor. Some air conditioners have a temperature sensor built inside the indoor unit to sense the room temperature. However, it requires the AC itself to be placed inside the room. Thus, it usually doesn't apply to central air conditioners. Thermostat. Duct air conditioners commonly use a thermostat to control temperature. The thermostat itself can sense its surrounding temperature. Thus, a thermostat must be located at a place where it is best to represent the room temperature. How air conditioners lower humidity. Most modern HVAC systems are capable of regulating humidity. Your HVAC system has an evaporator coil that condenses water vapor from the air, in a process similar to when condensation appears on the outside of a glass containing a cold beverage. This occurs when hot, moist air in your home comes in contact with the cold evaporator coil. The liquid is then condensed out of the air, making your home less humid. The moisture collected by the evaporator coil goes to a drain and then is sent outside, away from your home or office building. Some older air conditioners might have issues regulating the humidity in a home. Let us talk about air distribution systems. Air distribution systems include air handlers, ductwork, and associated components for heating, ventilating, and air conditioning buildings. They provide fresh air to maintain adequate indoor air quality while providing conditioned air to offset heating or cooling loads. Electric precipitators are used for air pollution control, particularly for removing harmful particulate matter from waste gases at industrial facilities and power generating stations. These are some pictures for your references. Now moving on to our next topic. Plumbing services. Plumbing services is the whole system of piping, fixtures, applications for providing water supply or drainage to the buildings with the use of pipes, control valves, pipe layouts, storage tanks, etc. Collection and disposal of wastewater with the use of water closets, urinals, traps, vents, anti-siphonage pipes, house sewers, house drains, etc. have to be separately dealt carefully for hygienic conditions. Principles of plumbing services. The following factors are to be viewed while designing plumbing services to buildings. The possible passages of gases, the odor of vermin from pipes and sewers into the building should be prevented. The foul and waste matter should be removed from buildings as quickly as possible. The drainage pipes used in plumbing systems should be airtight, gas-tight, and tough enough and durable to withstand the corrosive action of liquid wastes. Water supply and drainage pipe joints should be leak-proof, strong, and durable. The whole network of pipes used in plumbing services should have ample means of cleaning and removing barriers. Proper care has to be taken to check and rectify all possible airlocks, siphonage, under-deposits, and obstructions. Next. Pipe layout principles. The following rules should be used while laying of water supply lines. Ensure that there should not be any cross-connection and backflow. Backflow can be eliminated by providing an adequate air gap between the inlet and final flood level in all places, particularly wash basins. The inlet and float valve should be well fixed while connecting cistern to the water closet. Positive tension at the outlet pipes should always be ensured. Distribution line planning should be in such a way that it is easily accessible for inspection, replacement, and repairs. Water supply pipes and drainage pipes should not be laid very nearby to each other, especially drainage stoneware pipes. Ensure that water supply pipes should not be laid adjacent to the pipes carrying filthy water. GI pipes should not be buried, as they tend to deteriorate in contact with soils. All pipes, including PVC pipes, should be tested for leakage and set inside the building as concealed pipes. Determination of pipe sizes. Generally, for a middle-class house, the average number of pipes used is about 8 of minimum nominal size 20 mm diameter are enough. For water closets which are directly connected to overhead tanks, a 25 mm diameter is enough to get ample flow. Minimum recommended size of pipes for different purposes like for lavatory, water close, tank type, drinking fountain, the diameter of pipe should be 10 mm and for bathtub, shower stand, and the kitchen sink, 12 mm and for service pipe, 20 mm and for water closet, valve type, 25 mm. A gate valve or stop valve must be fixed in an accessible place to control the output from overhead tanks and also to stop the water during repairs. For multi-story buildings with many flats, a more complex arrangement of water distribution system should be adapted for uninterrupted water supply. This is about layout of building drainage. The following are the important factors to be considered in the design and construction of drainage layout. The layout should be simple and laid in straight lines both in horizontal and vertical directions. There should not be any abrupt changes in the direction of a pipeline which may affect the natural flow. To ensure a gradual and smooth flow, the contained angle between the intersecting pipes should be less than 45 degrees. At the points of intersection of pipes or wherever bends occur, it is necessary to provide inspection chambers. Drain pipes should not be laid under a building. If it is unavoidable, a cast iron pipe can be laid in straight with a uniform gradient. Man uses water for a variety of purposes. Disposal of wastewater, that is, used water from the kitchen, toilet, cleaning has to be dealt with carefully as they are essential elements for the human beings to live in a house with minimum comfort. Plumbing services provide water supply or drainage to the building with the use of pipes, control valves, pipe layout, storage tanks, etc. What are the 4 types of fittings? Coupling, adapter, bushing, and union fittings. For example, an adapter could be fitted on the end of a plain pipe to allow a threaded connection at the other side of the adapter. Bushing fittings, bushings, sometimes called reducer bushings, are used for connecting 2 pipes of different sizes. Check out these links to know more about the fittings. Plumbing fixture. A plumbing fixture is an exchangeable device which can be connected to a plumbing system to deliver and drain water. The most common plumbing fixtures are faucets, sinks, bathtubs, showers, and toilets. Each fixture should have a shut-off valve, or stop valve, installed for each water supply line that leads to the fixture. What are the water supply systems? Water supply systems are networks whose edges and nodes are pressure pipes and either pipe junctions, water sources, or end users, respectively. Their function is to provide end users with potable water with a sufficient pressure level. A WSS can be decomposed into hierarchically arranged tiers. Water distribution system, https://en.wikipedia.org/wiki/water_distribution_system. What are the types of water supply systems? The water distributed via municipal water supply systems should reach the end user with sufficient pressure and flow rates. In order to achieve this, 4 main water distribution system types are used. Gridiron systems. In gridiron systems, the main water supply line goes through the central part of the area, while sub-mains branch out perpendicular to the main line. This system has no dead ends, as all of the individual pipes are interconnected. This type of water supply system is great for cities that have a rectangular layout that resembles a gridiron. Ring systems. Circular or ring systems feature a supply main that forms a circle or ring around the area of distribution. In this system, the branches are cross-connected to the supply mains and each other. This type of system has similar advantages and disadvantages to gridiron systems and is suitable for towns and cities with well-planned roads and streets. Radial systems. In radial systems, the distribution area is divided into different distribution districts or zones. Each zone has an elevated distribution reservoir in the middle from which supply lines run in a radial pattern towards the distribution district periphery. Radial systems offer swift distribution and allow for simpler design calculations. Dead-end systems. Dead-end water supply systems are the best choice for cities and towns without definite road patterns. In this type of system, there is one main line that runs through the town or city with sub-mains branching off from left and right. These sub-mains then divide into a number of branch lines that provide service connections. The water supply system design in buildings. Designing schematic of the water supply system. Specifying the design properties of the fixtures. Diameters and equivalent lengths of fittings tables. Creating a water supply system in your project. Adding nodes. Adding pipes. Results of the design. Thank you for watching.